Hi class, today we're going to take a look at graphing an equation that's in slope-intercept form of a line. Now, when we were graphing things that were in this form before, we did graphing using a table, but there is a much quicker way to graph these particular types of equation. And we also had not discussed that this particular form where y was by itself actually had a name for it. It's called slope-intercept form. When you have an equation in that form, the y will be by itself, and on the other side of the line, you'll have some number m times x, and you'll notice that this number m is labeled m for a reason. We've already talked about slope as rise over run, and that slope is represented by an m. So it's actually not coincidence that this m in this equation is an m, because it is an m because that is representing the slope. So you'll have the slope times x plus some other value here that's on the end that we call b. And the b is a specific value that gives you a nice point on your graph. That b is actually your y-intercept, which is where you cross your y-axis. So if you look at this b, notice that when you replace x with 0, this part of the equation here will disappear and you're left with y being the b. So that means that we have a specific point just by looking at the equation. The value that is the constant on the end will give you your y-intercept as 0 for an x, and then whatever that value is, which is b in this case, for your y. So if we look at this equation, notice that we have a -1 here. This right here is telling us right away that we have a point that is the y-intercept at 0, -1. Now, it's possible to graph a line just knowing one point and what the slope is. And if you look at the equation, this 2/3 is the value being multiplied by the x, which notice that is actually the m. And the m is representing slope. So we know that this 2/3 for this equation is the slope, which means that our rise is 2 and our run is 3. What we're going to do on this particular type of problem when you have things in slope-intercept form is we'll begin at our y-intercept. You can think of it, your b is standing for where you begin. And then your slope here is going to tell you how to move. You can think of the m as representing move. So the slope will tell you how to move from this beginning spot to another point that's going to be on the line. So let's start by graphing our point that is our y-intercept at 0, -1. Now our slope tells us that from this point here at 0, -1, we need to go up 2, because we're going to rise 1, 2, and then run forward 1, 2, 3 to land at a new point, which is this point right here that has the coordinates 3, 1. So we'll go ahead and put a dot right here and label it as 3, 1. If we want to find another point, we can go up 1, 2 more and forward 1, 2, 3 more, and we land right here at 6, 2. 6, 3. So that point is right here, and its coordinates are 6, 3. Notice that each time, since your run is 3, each of these x values goes up by 3. And notice since your rise is 2, each of the y values are going up by 2. And that will be something that happens also. Now that we have at least 3 points on our graph, we can go ahead and just connect them. And there's your line. Now we're going to graph several lines, actually 3 of them to be specific, all on the same coordinate plane, and see if we notice something special about all of them. And I'm going to have them color-coded. The first line, the line we're going to compare everything to, is going to be y equals -1/3 x plus 2. Then We're also going to graph in red on the same coordinate plane y equals negative 1/3 x minus 1. And then on the same coordinate plane in blue, we're going to graph y equals positive 3 x plus 1. And then we're going to compare all three of them and see if we notice anything. So here's our coordinate plane. We're going to label the x and y axes and then put a few marks on here to label our scale. And then notice that all three lines are in slope-intercept form. So we are going to begin at the y-intercept, which will be the b in each of these equations. And then we will use the slope to determine how to move from that y-intercept to a new point. So we're going to start with our black line here. And the 2 here is the b on the end. So we know that the y-intercept for this is 0, 2. So we're going to plot that. And 0, 2 is right here, and that's where we're going to begin for this line. Then our slope for this line is negative 1/3, because that's the m, which is the value in being multiplied by x. That's telling us that we're going to go down 1 and then move forward 3 to find a new point, because the rise is negative 1 and the run is 3. So from this 0, 2, we're going to go down 1 and forward 1, 2, 3. And we land right here at 3, 1. So let's plot that. Now let's find a third point. We're going to go down 1 more and forward 1, 2, 3 more. And we land right here at 6, 0. Let's connect those and draw a line through them. And that is our first equation graphed on our coordinate plane. Let's take a look at the red one now. The red one has a b of negative 1. That means our y-intercept is negative 1. And to be specific, it's the point 0, negative 1. So let's plot that. That's right here at 0, negative 1. Now our slope is the value being multiplied by x, which is negative 1/3. So that means that our m is negative 1/3. So to find another point on the line, we're going to start at our y-intercept and then go down 1 and forward 3. So let's do that. We'll start here and go down 1 and forward 1, 2, 3. And we land right here at the point 3, negative 2. So let's go ahead and plot that point and label it. And then let's find a third point. We're going to go down 1 more and forward 1, 2, 3 more. And we land right here at the point 6, negative 3. So we will go ahead and plot that point and label it as 6, negative 3. Now we're going to go ahead and connect those and make our line. Now let's take a look at our two lines and see if we notice anything about them. One thing that I notice is, even though they're not completely to scale, we can tell that they're both parallel. They're never going to touch. They're going to go on forever and never touch. So let's think about what made these parallel. Well, notice that we have different y-intercepts, but both of them go down and over at the same rate, which means their slopes are the same. So what happens is when you have parallel lines, your slopes are the same. Notice that the slopes on both of them were negative 1/3. So if something is talking about two lines that are parallel, then you know the slopes are the same. So from these two, we can tell that parallel lines have equal slopes. Now let's move on to the blue line and graph it. If we take a look at it, the B on it is positive 1. That means our y-intercept is 0, 1. So our y-intercept is 0, 1. Let's go ahead and plot and label that. Now our m is our slope, which is the value multiplied by our x, and that's 3. So using that to graph, that's really 3 over 1. So our m is 3 over 1. That means we're going to rise 3 and then run 1 to find another point. So we will start at this 0, 1 and go up 1, 2, 3, and then move forward 1. And we land right here at the point 1, 4. So let's go ahead and plot that and label it. And then if we want to find a third point, we can go up from there 1, 2, 3 more, and forward 1 more, and we land at the point 2, 7. So we can go ahead and plot that. Now if we connect those, we get our blue line here. Now let's compare our blue line to the other 2 point lines. Notice that this blue line had a positive slope, so as we go the direction we read, it looks like it goes uphill. Whereas the other 2 lines had negative slopes, so as we go the direction that we read, it looks like they're going downhill. But even more than that, where they intersect right here, they're intersecting at 90-degree angles because they are perpendicular. The first 2 are perpendicular to the third one. Now let's see if we can see what might have made that happen. These were downhill lines and this was an uphill line. That's going to happen in order to get perpendicular lines. That means that the slopes have opposite signs. These were both negative and this one is positive. But even more than that, if we compare these values to this value is the reciprocal of these. So it looks like when we compare the blue line to the red and the black line that we find out that perpendicular lines have a special property. Perpendicular lines have slopes with opposite signs and are reciprocals. So if we have a slope of 4/5, the perpendicular slope would be negative 5/4. Another really neat property about this is if they are going to have opposite signs and be reciprocals, when you multiply them together, you're going to end up with negative 1, because multiplying these 2 together, notice you get negative 20 over 20, which is negative 1. If we take a look at the slopes here, multiplying the negative 1/3 times the positive 3 over 1, we get negative 3 over 3, which is still negative 1. So you can check to see if you have the correct slopes by multiplying them together and seeing if you get negative 1. If they have opposite signs and they are reciprocals, that should happen.